Hi there, welcome back again in another video in the Creative Technology Toolkit series that I'm putting onto YouTube from the Creative Technology MSc at UWE in Bristol. This week I'm going to do a short video looking at making and manipulating meshes, and I've overchefed it a little bit and added a little bit more explanation into the use of Perlin Noise, and we're going to do a bit of randomness and a little bit of 3D manipulation. So the first thing that I'm going to do is I am going to get the source code, which is at UWE Creative Technology on GitHub in the CT Toolkit sessions, and this is the mesh example. In the mesh example, it's fully documented, and you'll end up with something that looks like this and is animated, or is all lumpy and curvy and looks like this, whether we're using random noise or Perlin noise, which is kind of smooth and useful for a variety of different things. The code is available to download, and I've downloaded it here in the Toolkit sessions, and in the mesh example I'm going to open up my Xcode project, and this again will work Mac, PC, Linux. You can port it to Raspberry Pi, etc., and it should run fine straight out of the box. So I've got my Windows set up here. First thing that I'm going to do is have a look at the header file. I'm using just a few of the standard routines, and I have made a new mesh object, an openframeworks mesh object that I'm calling main mesh, and this is where I'm going to be making my 3D mesh manually from hand, not using one of the inbuilt 3D primitives like box, sphere, cone, etc. And there is also a plane object which you can make pre-formed. This one we're going to build ourselves from scratch by putting in all the points and actually triangulating to describe what the surface of this mesh is going to be. I've also made an EasyCam called mainCam, and I've set up a couple of variables just so that I can track them through my program without hiding magic numbers through my code for width and height, and a bunch of booleans to say whether we're going to use a messy mesh, Perlin mesh, and whether we're going to draw a wireframe or we're going to draw in just a point cloud. And then I've got a couple of floats that I'm going to use where I draw in the Perlin noise to describe how complex the Perlin noise is going to be, or how dense the Perlin noise is going to be, and the amplitude when I use it to distort my 3D mesh. The main parts are just this one, making a mesh. So I've made a mesh object, and I made a camera to look at it, and the rest is detail. When I come to my CPP file, this is where it all happens. So in my setup routine, I've set a width and a height that I'm going to build my mesh. So it's going to be 50 points by 50 points, and you can increase or decrease this depending upon the rendering power, how much detail you need, and exactly what else you want to do. And then I've set up a couple of my booleans, and I've just made them all false. And I've set a couple of basic values for how we're going to use the Perlin noise. So we're going to use two-dimensional Perlin noise. I think we're going to use two-dimensional Perlin noise. I'll check in the code earlier because I wrote this last week. But I've set up a couple of variables that work as a start point. Then I set the background to be white, and I've just set up a position for my camera, my EasyCam, to start looking at. So it's in the center at 0, 0, and then I've just given it a little bit of an offset in the Z value. The first thing that we're going to do is we're going to take our mesh object, so main mesh we call it, it's not openframeworks mesh object, and at the moment it has no information inside it. And we can put a series of points inside it to explain where vertices are, and then we can join the vertices together in configurations of 3 to make triangles that will be the face of the object. So the first thing that we're going to do is going to fill it full of points. So I have one loop which just iterates over the width. So we want our width to be 50, so it'll just go 1, 2, 3, 4, 5, up to 50, and at each point in that loop, it'll add a vertex point. Outside that, we've got a separate loop which will then iterate down the height 50. So it'll go across and then down one, go across and down one, go across and down one, just like we've seen when we've been accessing the information inside image arrays or from the video camera, that we're just going to scan across and click down until we get through our 50 by 50. So each time we go through this loop, we're going to say main mesh, use the routine that it knows how to do, add a vertex please. And it puts a vertex onto the end. So initially the first vertex will be vertex 0, and then 1 and 2 and 3 and 4 and 5, etc., etc., until we get to 50 by 50 vertices. And I need to pass this either a vector3 object or an x, y, z position. So vertex 0 is going to exist somewhere in space, across, down, and forwards or backwards. So I give it an x, y, z position, and then the next one exactly the same, and on through all of our vertices. So I'm going to add a point in space at whatever loop we're in this. We start with 0 and go on. And I'm going to say make a point value at wherever we are in the width and height. So we use the integers that we're counting through in our loops to give it the x, y, z position of each of our points. So the first one will be at 0, 0, and then 0, 1, 0, 2, 0, 3, and on to 50, and then 1, 0, 1, 1, 1, 2, and on. So I'm using the width and the height that we're counting through, and then the third value that I'm passing it, the z value, is 0. So if we're looking at it flat on, we'll see an array of points in a 50 by 50 grid, and they'll all be at z position 0. So in the forwards and backwards, they'll have no offset forwards or backwards. And then the only other thing that I'm going to do is make a color of black. So 0, 0, 0 just here. I'm going to make this a little larger using ofFloat color. And I'm just going to say main mesh, use the routine that you know of, the method you know of, add color. So I'm going to make a point in space and then tell that to be a particular color, in this instance black. And if you want to mess around, just put ofRandom in there and generate values between 0 and 255 and throw them in, and you'll have random points in your loop. So we make a grid of 50 by 50 points, we color them all black, and now what we want to do is go through and turn that into a surface by joining them together in a particular way to make a wireframe mesh. At the moment they're just points, like a point cloud, so they have no surface detail. We can say the points should be rendered at a different size and see it much more easily, but they don't have a surface at the moment. So what we want to do is add indices into the mesh object. So we've had vertices, all the dots. Now we're going to add indices to say this dot is joined to this dot is joined to this dot, and then by inference it'll join back to the first one to make a triangle. So we start off with dot 0, point 0. We want to link it to point 1, and then we want to link it on to point 0 on the next line down. So it'll make a triangle between the row, and then we'll do the inverse. So we'll take point 1 and we'll go to point 1 on the next line down, point 0 on the next line down, and then point 1 again. So we make these two converse triangles that make a square, and then we move on all the way through the grid. So again, we're going to count through our width and our height, but we're going to stop one before the end because of how we count up. And basically, we start off linking point 0 to point 1, and then point 1, actually not to point 10, but it's point 1 in the second row, which will be point 50, i.e. the 51st point. And then back again to 0 to form our first triangle, and then we do exactly the same for the if one is a left-handed triangle, for the right-handed triangle to make a square. I should do some drawings with this. But this is what we do. Because we're making triangles and not quads, so 3 points rather than 4, we need to put 3 indices, and we just describe what they are, and that will form us a triangle. And then we do the left-hand triangle first, the right-hand triangle, and that forms a square. And then we just count through the whole grid. So we make all the points, and then we use this routine to tell which points are joined together to make the triangles. And we set up our mesh. I'm going to move past the update at the moment. We've got our mesh. It's a wireframe grid, all joined together, and all we need to do is say mesh, draw wireframe, and it'll draw us a wireframe. Alternatively, we can just say draw only the dots as a point cloud, in which case we can say mesh, draw vertices. And if I compile this, let's have a look what that looks like. And drink coffee. So here we go. It's compiled, it's running. You can see I've got a mesh of 50 by 50, and on my mouse or my trackpad, because I'm running EasyCam, I can zoom in and I can have a look at that mesh, and you can see it's got 0 thickness, but there is my mesh made up of all my triangles of right-hand and left-hand pairs, and I can move the camera around and have a look at it. So I can build a mesh any way that I want. And just to show you, if I come down and set the mesh to be, for instance, 10 by 10 here in the setup, so it's going to count 10 across and 10 down, and recompile, here is my 10 by 10 mesh. I'm just going to change this back to 50 by 50 because it gives us a nice smooth example. So we've set up our mesh, we've put a whole load of vertices, points in there, and then we've explained to the mesh how the vertices are joined together to make our surface. In the update, I've got two simple routines. One is saying if the Boolean messy mesh is true, we set them all to false to start with, then go get the main mesh and ask it how many vertices are in there, i.e. how many dots. And it will come back and say, well, there's 50 by 50 dots, which is 2,500 points. So it'll loop through this 2,500 points, or however many points there are. And all I'm doing inside is saying, make a new vector3 object, i.e. an object with an XYZ position inside it, and find out what the current position of vertex, starting with 1, looping through to 2,500, whatever the vertex is, and it'll bring back its X position, Y position, and Z being 0. Because if you remember, when we made all of our vertices, this last digit, this last integer is 0, and that was the Z position forwards and backwards. But here in update, I'm going to say, set the Z position of our vector3 object to be random, anywhere between -1 and 1. So it'll give us a random height between -1 and 1, and then I just say, set whatever vertex we've just pulled the values from to our new position. So it'll keep its X position and its Y position, but it'll now have this random Z position, and it will loop through that. And in my key pressed routine, I'm using the switch statement again, where you can see I've got toggle full screen. And here, if I press the space bar, it just toggles the Boolean messy mesh to be on or off. So if it's on, it'll generate these random Z values for each point in our mesh, which will look a little bit like this. Building, compiling. It'll bring me up my mesh, and here it is. If I run this full screen, we can have a better look at it. So there's my mesh, and if I press the space bar, it'll set that Boolean to be true, and every update, it'll go through and alter the Z value of each of the points in the mesh, like that. So the X and the Y position is staying the same. So if we could line this up perfectly to look at from the front, each X and Y position of each vertex is staying exactly the same. But the Z position we're randomly, so we get this groovy kind of bouncing thing, and then I can switch it off. And because I haven't zeroed all the Z values, you can see it retains them. So I'm able to build random surfaces, and if I wanted, I could use that random value to make the X and the Y positions change, and the points will all jiggle about, and we'll get odd-shaped triangles at every point. What I can also do is, rather than using very, very random noise, I can use Perlin noise, which gives me smoothed randomness, which is exactly what I'm going to do. I have a second routine in update that runs off this second Boolean Perlin mesh, which in my key pressed, if I press the P key, it just toggles that Boolean Perlin mesh to be not Perlin mesh. So if it's true, it'll be false. If it's false, it'll be true. And if I have got Perlin mesh Boolean true, it goes through, and again, exactly the same as this first loop, and I could actually probably tidy these loops up because I'm repeating myself a little bit here. It loops through every point in our mesh. It pulls the position of each vertex exactly like we did before, but instead of using a random value for the Z height, I'm using, instead of ofRandom, I'm using ofNoise, which is a function that pulls Perlin noise, and I'm then using the map function and supplying it with whatever the value of X is that we're going through, and 0, and I'm mapping from the width through to the maximum of my Perlin range integer, which I set up here. So it starts out as 1. And I'm using this to seed the Perlin noise. So I'm saying incrementally go through and use this as a trigger. Often people will use time because it's an incremental value. And whenever I give Perlin noise a particular value as a start point, it always returns me the same random value back. But if I move a little bit from the value I've just passed to Perlin noise, it'll pass me back a value that's close to what I've just had. So it's not very, very jagged random, it's actually smooth random. And depending upon the steps of the value that I pass to Perlin noise, gives me how tight or how smooth that randomness is going to be. So I use ofNoise, and I pass it my first number, and then I pass it my second number. So I'm using X as one value and Y as a second value, and just mapping them so that they map between the 0 and Perlin range, which is whatever our value of X is. In this instance, it's going from 0 to 50. Remap it to 0 to whatever our maximum Perlin range is. So I'm going to pass it at the moment a value between 0 and the width of our mesh, which is 50. So I'm saying use the map, you're going to get something between 0 and 50, and return me something between 0 and whatever is in Perlin range. At the moment it's 1. So this will bring back a value between 0 and 1, and the same for our second number. I'm going to pass it Y, but it can be between 0 and the height of our mesh, and give me back something between 0 and whatever's in Perlin range, which is at the moment 1. So I pass ofNoise 2 numbers between 0 and 1, and I get back 2-dimensional Perlin noise, which means that not only does it give me a smooth line, if it were a flat surface, it will give me a smooth ripple in both dimensions of the surface. And then the value that I get back, I'm just multiplying by Perlin height, which says Perlin noise will give me a number back between -1, 0 and 1. If I'm wrong, somebody will shout at me about that. And then I'm just going to multiply it to increase the amplitude of the noise that's coming back. And then again, I use that to set the mesh, the X position in the mesh. And then all I've got to tidy this up a little bit is I've put in two case statements here for the up key and the down key, and then the right key. So case, I'm using this a special reserve word of key right rather than previously where I'm actually using the letter. So whatever is the right key or the left key or the up key or the down key on your particular key flavor of keyboard, it'll trigger these to increase or decrease the Perlin range and increase or decrease the Perlin height value. We'll see that running right now. So when I press the P key, it'll start the Perlin noise off, and I can have a look at what that does. So I build my mesh, I press the F key, goes full screen. Let's have a look at this. And if I press P, I get Perlin noise. And you can see that the noise that's manipulating the Z value is smooth. It transitions from one place to the other. Whereas if I were using the wireframe, it's very, very streaky and rough. But if I go to Perlin noise, you can see I get this lovely smooth distortion. And if I use my left and my right key, left and right key, I'm increasing and decreasing the amplitude of the Perlin noise. So the randomness isn't changing, just the height that I'm distorting the mesh by. And you can see that working there. Now, if I use the up and down keys, I'm increasing or decreasing the range of the Perlin noise, so the step size. And you'll see I have this noise and it's either getting more grainy or more detailed or less. So I'm going to just reduce the amplitude a little bit, and you can see that I get these smooth distortions, but the tighter and tighter I force the grain, the more chaotic the randomness appears to be. And at any point I can also increase or decrease the amplitude that I'm using to distort that mesh. There's one more thing that I put in here, so I'm going to pause that, is when I press the W key, I use this other boolean, draw wireframe, to be true or false. And in my draw routine, all I'm saying is, if draw wireframe is true, then say main mesh, use a draw wireframe method. Otherwise, main mesh, draw the vertices. And then I have a little bit down here where I make a string and I put my values on the screen and use ofDraw bitmap, draw the message on the screen. This is the bit we're interested in. The main mesh, I can tell it to draw itself in a couple of different ways. Wireframe or vertices. And this is what it looks like. So compile and build again. I'm going to run full screen. And if I press the W key, you can see I'm not drawing the wireframe, I'm just drawing the vertices. And there are all of the points in my mesh. And if I press Perlin noise, you can see we can get some very, very interesting effects just with our point cloud. And again, I can manipulate that, or I can go to my random noise, and you can see here where from the front I'm not manipulating the X and the Y position, but from the side you can see I'm manipulating the Z position, or in Perlin noise. So that's a quick introduction to using the openframeworks mesh object, showing you how to make vertices and then connect them to make surfaces. And if I wanted, I could put lighting in and render this as a surface and do a bunch of other things. There's a lot more to what's going on with 3D graphics, especially when you come to lighting and surfacing and texturing, but that's for another time. Right now, you can very easily build meshes, and you can pull the values from anywhere to control your meshes, whether it's from the keyboard, from random algorithms, from the weather, whatever else you like. Have a go, investigate. If you've got any questions, drop me a line. And the source code is all downloadable. And I'll be making some more videos, and keep an eye out for them. So thanks very much.